let's look at another one. So we have now a basketball shot can be modeled by this equation. H of D equals negative 0.09 D squared plus 0.9 D plus 2, where H of D is the height of the basketball in meters and D is the horizontal distance from the ball in meters. Now that looks like a whole lot of gobbledygook to me, so we need to actually interpret what we have here. We already have, first of all, a quadratic equation, or quadratic function. It's given to us. This makes us very, very happy because we don't have to create this equation or this function. To figure out the maximum, we still need to take this that's in standard form and write it in general form. Of course, we're still going to have to complete the square on that, but it's already done for us. So the equation itself is already established. So to find the maximum height, we are concerned about where is the maximum h and what the d value is at that maximum height. So that's what we have to do. Now, again, we can't tell anything from the equation in this form. This just tells us to start with that and complete the square. So let's go at completing the square here. So we're going to get h of d, and we're going to have to factor out negative 0.09, and we're going to get d squared. Now, if you have 0.9 and you factor out negative 0.09, we're going to get negative 10d, and plus 2 is going to be on the outside there. So we have negative 0.09 d squared. Half of negative 10 is negative 5. So we're going to get d squared minus 10d plus 25 and minus 25. And then that plus 2 is, of course, kicking around. So once we've completed the square, we can go d squared minus 10d plus 25, and of course we want to keep that positive on the inside as always, and we're going to now take the 25 out. Now to take the 25 out though, we need to multiply it by negative 0.09, and negative 0.09 times negative 25 is plus 2.25. And what's our equation when it's all said and done? Negative 0.09 d minus 5 all squared plus 4.25. There is our equation. All we've done is manipulated it, completed the square on it, and got to this point. Now, what's the maximum height of the ball? Well, this is even easier now. Once it's in this form, we're trying to figure out what is the maximum h, the height. Well, the maximum height is right over here. Once we've done all the work, we can figure it out right from the equation. We need to be able to interpret it from the equation, but all the work's done. So we can just look at this equation and say that the maximum height is 4.25 meters. Now, we also have to make that make sense. If someone's shooting a basketball, is 4.25 a reasonable answer? It definitely is. 4.25, that, you know, a basketball hoop is about 3 meters, a little higher than 3 meters. Maximum shot, 4.25, very reasonable. If I got a maximum height here of 425, I have made a mistake because it has to make sense. So this answer definitely makes sense. It has to be a positive value. You can't shoot a basketball into the ground, so it has to be a positive value. So that is the maximum height. So let's look at part B. What is the horizontal distance of the ball from the player when it reaches the maximum height? So what I'm going to do is I'm just going to rewrite this equation. But h of d is going to equal negative 0.09 d minus 5 squared plus 4.25. Now, what is the horizontal distance of the ball when it reaches the maximum height? Well, we have that too. We have that right here. This tells us that this maximum height of 4.25 meters occurs when d is equal to 5. And d is the horizontal distance. Problem solved. We've got it figured out. We can solve it right from our equation. And that's how powerful that equation is the horizontal distance is 5 meters. Problem solved. Just read it from the equation. Now, the next one is a little bit trickier, but not a lot. How far from the floor is the ball when the player releases it? Now, this is where we have to do a little bit of thinking in advance. Is if we look at our equation here, d is the horizontal distance of the ball from the player in meters. Now, when the player is first shooting the ball, how far would he be, or she, away from the ball? So when you're first shooting, what is your horizontal distance from the ball? Well, it's been a long time since I played basketball, but I'm pretty sure if you're trying to take a shot, it's in your hands. So you are not any distance away. So what we have to do here is our d value, the horizontal distance from the ball, is actually equal to 0. So what we're trying to figure out is what is the height when d is equal to 0. Now, here's where we have to use some of our math logic. This is the equation that we established. We could put d equals 0 in here. We could square it all out and figure out what h is. But here's an easier way. Let's look up, 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 way up. Here's this equation right here. Both of these equations are identical. They mean the same thing. It's the same equation, just written in two different forms. If I use this equation right here, and I have to put d equals 0 in there, without any math, I can solve this problem. So I can just go, h of 0 is going to be negative 0.09 times 0 squared plus 0.9 times 0 plus 2. Oh, 0 is our best friend because it becomes 0 plus 2, and it equals 2. So how far is the floor? How far from the floor is the ball when the player releases it? The ball is 2 meters from the floor. So fairly straightforward. If we think about those problems, take 30 seconds to really think about what's going on, we can solve these problems rather simply.